Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim, and hey everybody, thanks for plugging in today to the TTI Distribution Download. Today I'm very excited to be joined by our partners from YAGEO, Dr. Phil Lessner and Mark Laps. Dr. Lessner, I have followed you on LinkedIn for a long time. For our listeners today who have yet to follow you on LinkedIn, tell us a little bit about your role at YAGEO and what is your purview?
Sure, Paula. I'm YAGEO's Chief Technology Officer. I overlook the global R&D. So that includes material, process, and development of new products. Globally, the R&D groups report to the business heads, but I overlook the cross-business group work and advanced material type of product development.
And you've been doing this with YAGEO for a long time.
Yeah, so actually before YAGEO acquired Chemet, I was Chemet's CTO, so I was been in that position since 2006, and then YAGEO acquired us in 2020, and I've been YAGEO's CTO since the beginning of this year.
Well, thank you again for coming in and joining us in the studios. As I said earlier, I'm quite excited to have you here. And Mark, while I didn't know you before, I'm very excited to have you here also. Joining us also today is Mark Laps, Technical Product Manager of Ceramic Product and Business Unit. Tell us a little bit about your journey.
Yes, so I graduated in 2004, and I joined Chemet in 2006 as an electrical test engineer for ceramics. So I've been doing that till about 2016, joining the product management group as the technical product manager. So I'm responsible for the product launches, technical collateral, and tools under the Chemet brand.
Awesome. Welcome to you again. So this is our first in a three-part series talking about artificial intelligence. So let's start with you, Dr. Lessner. Give us the overview. What is AI?
Okay, yeah, so AI is a popular topic these days, so let me try to give a short definition. So AI, at its most basic, is the simulation of intelligent behavior on machines. Usually, for AI, we use a technique called machine learning. And this is a type of AI that provides computers with the ability to learn from a model from data and generalize that learning to new data. So it can either be restricted to a narrow domain like image recognition, or it can be applied to multiple applications like the recent generative AI systems like ChatGPT that can answer general questions. The basis behind these AI systems in modern machine learning is a technique called deep learning, which is the rough simulation of the processes of the brain that uses artificial neural networks.
Tell us where AI is currently being used today. I mean, I know in the beginning we used it to play checkers, right?
Glad you asked that question. So one of the first applications of AI was really spam detection in email. So it didn't use the modern deep learning techniques, but used some older, more historical machine learning techniques. Now AI is applied to diverse fields like image and voice recognition, language translation, traffic routing, product recommendations. And these applications have become increasingly accurate over the past several years, in some cases surpassing the accuracy that a human being can have. Really, in the last year and a half, there's been these powerful generative AI applications that have been released, like ChatGPT and generating images from text. A lot of consumer applications are now based on AI, but we can't forget that AI is also used in a lot of industrial applications like automatic image recognition and stuff for testing product quality.
So we recognize this path, and as you say, we've been at this for a long time, and all of those applications you mentioned, I recognize. Why so hot today?
Yeah, so let's just talk a little bit about the history of AI. So actually, the artificial neuron goes back about 80 years, but it wasn't until the late 1980s that scientists and engineers actually figured out how to efficiently train and use neural networks. And then it was actually about another 20 years until we saw the first real applications of AI. So those were around the 2010, 2011 time period. And the reason for that is twofold, because there's two other ingredients that are required in addition to the algorithms. One is lots and lots of data to train these AI models. And that data came really from the advent of the internet. So before the internet, it was difficult to get, images and documents and stuff. But then when they became available on the internet, suddenly there were millions and billions of these images, videos, and documents available for training the model. The other ingredient is computational power. So back in the 80s, when they first figured out how to train these neural networks, there wasn't a lot of computational power available, and that's, of course, due to Moore's law, steadily increased over the years. But the real breakthrough was, a couple of decades ago with the advent of the GPU, or graphic processing unit, which turns out to be, perfect for processing the parallel computations required for AI. So it's really the combination of the algorithms, the data availability, and the processing power that's really made AI a hot topic and forward-looking applications today.
Really, really coming into its own. So what is AI's impact on personal and business use today?
Yeah, so there's a lot of questions around AI and its use, and obviously this is an evolving area of the law that certainly hasn't been settled yet. So as I said, training is basically done using the vast resources of the internet, and a lot of that material on the internet, like from newspapers and such, is copyrighted material. So there's questions around whether training AI on that material constitutes fair use under copyright law, and then there's the desire of the copyright holders to actually monetize what they believe is valuable data that they have. So there's a lot of discussions going on between the companies that are developing these AI models and these copyright holders.
Yeah, it's certainly a very big, ChatGPT is a very big topic in my arena in marketing today for all of those reasons, especially the copyright you just said.
Yeah, and then there's issues around privacy and confidentiality. So when you upload something to one of these large language models like ChatGPT, it's basically going on to a public server. So there's concerns by companies about uploading confidential information to these servers, and there's concerns about confidential company information being used for training these models, which then could potentially give an advantage to a competitor of the company. So a lot of companies are restricting the use of these models, or they're developing their own in-house versions that run, locally in their data centers or their private servers. Another trend affecting, the privacy is actually, instead of running these models on the public cloud, is actually running AI at the edge. So running these models like on your smartphone or computer. And that's really been enabled by the increasing computational power of our smartphones and tablets of computers. And there are several companies out there developing neural processors that are specific to running these models locally on the phone or the tablet. And then, last issue I'd like to point out is an issue of accuracy. So AI chatbots like ChatGPT and Bard from Google and Claude are all subject to something called hallucination, where they basically make up answers and they sound very convincing. So that's a big problem. I mean, there was a famous news article a few months ago about a lawyer who used one of these large language models, and it quoted to him some case law that didn't exist, and he used it in his brief, and obviously it didn't go well for him. So really, the advice here is, if you're using one of these models, please check the data that you get for accuracy.
Do your research the hard way.
Yeah, do your research in more than one way. Yes.
What about jobs? So this is bringing a lot of efficiency into the workplace, right?
Mm-hmm. Right. So that's an interesting question because, early AI systems, ones that were developed maybe 10 or 15 years ago at the sort of the advent of the AI age, mainly were replacing lower level tasks. So they were mainly automating away blue collar jobs. But now the AI has become sophisticated enough that it can do some of these higher level tasks like writing documents or working on spreadsheets. So, that's a good thing for the office worker, for the knowledge worker, because it can really assist them in completing the task, but there's a concern now that the AI will get good enough that it will actually be able to replace these workers. And we see that, sort of playing out in Hollywood now with the writer's strike, and part of the issue there is, potential replacement by these AI systems.
Well, thank you for that great explanation and overview. So, Mark, I'm going to turn to you now as technical product manager at YAGEO. How are you capturing the voice of the customer in your component roadmaps?
Yeah, thank you. So road mapping is a tool used to align a company's technology and product development efforts to the needs of the customer. You can think of it as a strategic process of identifying the gaps between where we are now and where we need to be. Now, the only way to stay ahead of this trend is to make sure that the technology and the product roadmaps are aligned with our customers' roadmaps. Now, this is critical since it allows us to be proactive, sense the market not just 12 months from now, but 3 to 5 years from now. And we need to be looking out even 10 years from now. So consider a scenario where this technology, artificial intelligence, really begins to take off and leading edge components are not available to the design engineer. This really prevents the design engineer from pushing those boundaries of development and may even suppress the natural growth of this technology. So there really needs to be a pattern of continuously innovating and adapting from the component suppliers. So there are many use cases for artificial intelligence as well as potential use cases that's really going to lead to significant growth in the next 10 years. This is why we're using road mapping to capture the voice of the customer. This is something that we really need to stay ahead of the curve with. So this is not something that's new for YAGEO. We're already road mapping other areas such as electric vehicles, Industry 4.0, defense and aerospace, downhole. So again, it's not something new. So if you look at EV charging, for example, we've been following two big trends there. And really it's about power efficiency and power density, specifically with things like onboard chargers and DC fast charging. And what we've been looking at over the past few years is new technologies such as wide bandgap semiconductors being adopted. So you can look at the transition from silicon to silicon carbide or gallium nitride, where these power converters are now operating at higher temperatures, higher voltages, and higher frequencies, all with an effort to reduce cooling, use smaller components, and overall have much smaller power converters with very high efficiency and high power density. So we have to take those attributes of wide bandgap semiconductors and take that down to the component level. What does that mean? So higher temperatures, meaning we need capacitors and components that operate at higher temperatures. These have to operate at higher voltages and then also higher frequencies. So we have to link these trends down to the component level using our roadmaps. Then you look at LLC resonant converters that utilize 0-volt switching to drastically reduce switching losses in the DC to DC conversion process, and that results in higher frequencies. So what does that mean for YAGEO? So we see this new trend of moving from film to ceramics, for example, for the resonant capacitor. So those usually lead to capacitors that need much higher AC voltage capability, high AC current, and now you have thermal effects that need to be managed. So by looking at these technologies that are being adopted in the EV industries, we're able to use roadmaps to develop technologies and products to meet those trends. So actually, both of these trends are not really unique to electric vehicles. I mean, they're also being adopted in AI applications, specifically with the power conversion process. So you look at an example of artificial intelligence and deep learning consuming massive amounts of power 24 hours a day, 7 days a week. You call that brute force computing, for example. So the big focus there is really power density and power efficiency. So what does that mean from a road mapping perspective? So we have to link what technologies and products that we develop now to meet the demands supporting the hardware for efficient power conversion. And we've been doing that. So we've been developing and continue to develop a broad range of solutions that's really going to support this trend.
Understanding, as you said, road mapping is part of your business model always. Is AI causing you to look further out than you have before?
Well, I mean, when we look at the electric vehicle market, 1 year out, 3 to 5 years out, to see what the trends are, what technologies are being adopted, and artificial intelligence is no different. It's a little on the newer side compared to electric vehicles. So that is something where we are looking, 1 year out, 3 to 5 years out, and looking even beyond. What does that mean from not only a technology standpoint but a capacity standpoint? How is that going to impact the components, the component suppliers?
So how big will this be? When I was doing my research, I read it's going to be bigger than the internet.
So I think the consensus is it's going to be big. And they say it's coming at us like a tsunami and has the potential to be one of the most transformative technologies that we've ever looked at. Sundar Pichai, the CEO of Alphabet and Google, he called artificial intelligence the most profound technology that humanity is working on, more profound than electricity, that's going to be far more capable than anything that we've seen before. So it's hard to comprehend just how big something like artificial intelligence is going to end up being. I mean, could we have imagined how big the internet was going to be when we first started logging on to America Online? Now everything that we have is connected to the internet. You think of TVs, phones, watches, thermostats, even our refrigerators are now connecting to the internet. And now we have a need to connect our refrigerator to the internet for some reason. So I think they said there's currently something around 15 billion devices connected to the internet. I mean, if we go somewhere and it's not connected to the internet, I mean, we're shocked, right?
Right.
If something's not on the internet, when we search for it in Google, I mean, we just probably conclude it probably doesn't exist, right?
Yeah.
So, but even as big as the internet is, it's still conceivable that artificial intelligence may be bigger than that. When we think about the internet and specifically with data collection, for example, that's something that we've gotten very good at as a society. See, I think the data says in 2021, over 79 zettabytes of data existed, and it's going to double by 2025. Now, just to put that in perspective, if a typical home computer was 500 gigabytes, we would need over 300 billion home computers to hold that much data. So our ability to create data has exceeded our ability to process the data, learn from the data, and make decisions from that data. So we need AI and deep learning capability along with that brute force computing to do something of value with our ability to collect all of this data. So when you look at some of the current use cases for AI and machine learning and deep learning, you have things like chatbots, spam detection, personalized shopping recommendations. Those are just, to name a few that we use every day. But if you go a little deeper, you look into healthcare where AI is being used to analyze patient history and symptoms to predict their medical diagnosis and predict their likelihood of certain diseases and even recommend diet changes. Not that we would actually follow those recommendations, but at least we know that it's,
Right.
it's there. You look at what Google DeepMind was able to do, was able to solve all the protein structures known to the science community in less than a year when it would have taken 1 billion years using the traditional method. Tesla's using AI and deep learning to train their vehicles for autonomous driving. You look at buildings today, we're filling these buildings with IoT devices that are collecting data, air conditioning systems, power distribution systems, solar security cameras, all incorporating these IoT systems that are collecting data every second. But what do you do with all that data? How can you leverage the data to make better decisions regarding building management? I mean, this is something that you can't do manually. This is where AI can be leveraged to take this massive amount of data to process it, run simulations and analysis, and make decisions so the buildings can run more efficiently. So this really just scratches the surface of the potential of AI and how big it can be. I mean, even a little bit of research on the internet, you see the potential for AI in pretty much every industry. So there's immense opportunities. Some market estimates, the total market for AI is close to $2 trillion by 2030 with an annual growth rate of something like over 20%. So it's huge. And this is kind of a mix between hardware, software, and services. So to come back to the question, the answer is yes, it definitely can be bigger than the internet. And this is why we have to pay very close attention to the market as it evolves over the coming years. This will certainly have a major impact on the electronics industry all the way down to the component level, which is why road mapping is critical to stay ahead of this curve.
So how is YAGEO supporting this mega trend? When you talk about staying ahead in component, new technology explosion, my mind goes to allocation.
Yeah. So there's really three ways. Number one is customer engagement. So like I mentioned before, we need to be engaged with our customers to understand the true voice of the customer. We can't wait till our customers come to us when they need a solution. We need to be continuously engaging with them to make sure that we are aligned from a technology and product development standpoint. The second one is we have to have the right products. So YAGEO has been expanding its portfolio over the past 3 decades with new and innovative products and also key acquisitions. This has allowed us to have a very broad portfolio of components that's really going to be needed to support artificial intelligence. Now, and the third one is capacity. So many are aware of the MLCC capacity crunch in 2018. That had a pretty major,
there you go.
Yeah, had a pretty major impact on electronics. With AI now seeing significant growth rates over the next 10 years, the demand's going to continue to increase. So YAGEO has been investing significantly in AI, including MLCC. So we've added a new factory in Kaohsiung, Taiwan, as well as increasing our MLCC production in Monterrey, Mexico. So again, YAGEO is supporting this trend through customer engagement, having the right products, and having the capacity.
And as I know you know, and I'll remind our listeners, and TTI is a big believer in inventory, available to sell inventory.
Yes.
Well, thank you for that, Mark, and thank you, Dr. Lessner, also. And you guys are going to stick around. We'll talk some more on episode 3 with you, Mark. On episode 2, we're looking forward to talking to Peter Blaze, Senior Director in Application Engineering, YAGEO Americas. We're going to talk about how AI is impacting our industry. In the meantime, I encourage you to stop by tti.com/marketeye to read Dr. Lessner's article, Advancing Artificial Intelligence, YAGEO's Role in Powering the AI Revolution.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.